Welcome to the Automotive Diagnostic Podcast. We're going to explore ways to sharpen our diagnostic skills, find learning resources, and hear from experts in the automotive field. This episode is brought to you by AutoRescueTools.com and Isaac Rodell. If you are looking to get into module programming, but you are not sure what kind of laptop you're going to need or how to set it up for programming, Isaac is your guy. He can set up laptops specifically to do control module programming for specific brands with partitioned hard drives and all the software that you're going to need to do this. He also sells key cutting equipment, scan tools, and other diagnostic equipment. I bought some stuff from him in the past, and the support is phenomenal. So I highly recommend checking out the website. Again, that's AutoRescueTools.com. The link will be in the show notes. Hey, what's going on, automotive world? Welcome to another episode of the Automotive Diagnostic Podcast. My name is Sean Tipping. I'll be your host once again for this week's episode. Thank you so much for joining me. On the show this week, I've got another Parasitic draw case study here for you. This one was kind of interesting. Spoiler alert, if I had gone on Identifix, probably could have got to the conclusion on this one a lot faster with some visual inspection. But I would not have learned as much as I did along the way, and that's kind of why I'm talking about it. I think the way that the draw presented itself in this case was actually pretty interesting. I learned some stuff about the circuitry, how this is set up, the wiring diagrams on this vehicle, and again, just the way the draw ended up happening, I thought was interesting and well worth the actual investigation as to why the electrical component that was on causing the draw was actually on. It wasn't the thing that was actually drawing, that was taking the current from the battery, was not the problem. It was not that component's fault that it was awake drawing current from the battery. Is actually something else. And the thing that was at fault wasn't actually drawing any current. It's a potential for drawing current, but it wasn't the thing drawing current. So anyways, I find that interesting to actually track it down and figure it out. Now, again, had you gone on Identifix, probably could have found this real quick. I did not do that in the moment. I did it afterwards when I was making my notes for this case study. But, again, I like to, I don't know if suffer through is the right word, but I like to, ride that struggle bus and, use my own knowledge and skill and wits to be able to find the source of the problem, even if it takes me a little bit longer. Now, it might depend on the situation that I'm in, maybe the time that I have available, or how much effort I've put in, whether I start accessing, databases with fixes. But in this case, I didn't until after. Anyways, just want to mention that in case somebody pops up Identifix, like, bro, why'd you go through all this? It's the top hit. So anyways, this is a 2016 Chevy Silverado, parasitic draw, and the battery goes dead overnight. So very quickly, it's consistent, it's not intermittent, it's all the time. I do a quick check just to see what is the draw on the battery. You wait about 5 minutes on these things and they should be almost completely asleep by that point, at least under a half an amp by that point. And I'm still up at 2.8 amps, and that does not seem to go away. Wait about 5 minutes and it's still at 2.8 amps. That's too much. And it correlates with what the shop is saying, that the battery is dying overnight. Okay, so we got a big draw. Where do we go with this? Standard parasitic draw procedure, how I'm going to follow this. If you'd like to watch the YouTube video, there's some diagrams and some pictures of my actual measurements. As always, I'll do my best to explain everything audio only, so you don't need the diagrams. But if you want to check out the YouTube channel, do note the YouTube video is generally a day or two delayed from when I put out the podcast. So if you are like right on it, you're listening to this episode as soon as it drops in the podcast players, the video might not be available to you for another day or so, maybe Monday afternoon, Tuesday morning. So do keep that in mind. But I will have video up for this, so you can make the decision if you want to wait and watch the video, or maybe you are watching the video. Who knows? Um, anyways, I have diagrams and stuff. All the diagrams that I use are courtesy of All Data. We have permission to use them. Uh, I like using them for service information. I like the way they organize it. I use Identifix too. I'm not sponsored by either one of them. Those are just the two services that I use for information and particularly wiring diagrams. Anyways, that's diagrams that you're going to see. But anyways, I'm going to use a wiring diagram. And actually, I didn't even really need it for this one. But generally speaking, when I'm beginning my parasitic draw, you want to do a pre-scan of the vehicle. Of course, that didn't really come up with anything for me. Set up your vehicle for a draw, door latches, hood switches, key, all that good stuff. I'm not going to go through all that. I have other episodes outlining the procedure. You've probably done a few of these yourself, but the first goal that I have on any parasitic draw is to figure out what path off of the battery is the current going. All right. Now, this is really going to depend on your setup, how easy or how much information this actually gets you. But I find in Silverados and Sierras in particular, the way they have the power distribution right off of that fuse panel that's on top of the battery. This is a 16 Silverado, so it has like a big fuse assembly on top of the battery with multiple cables going off of it for the positive side. I can take my amp clamp, and I use that Unity amp clamp. That's $50, and I can go onto each cable and see, is their current going through it. Now, I can also just clamp around the two negative cables, which is what I did to start with, to determine what is the overall draw. Right. First step, how much current is actually leaving the battery total. Okay. And that was about 2.8 amps. Now, what's its path out of the battery? Because most likely I'm going to have it going to one major hub. It's probably going to be a power distribution center, fuse block, something like that, but not always, right? It could be the alternator. And I've had that where the alternator is the draw. And that's how you would quickly identify that, is by checking the amperage draw out of each cable on the battery. Now, again, some makes and models don't make that as easy. Others do. This one makes it real simple. I can just take my amp clamp, put it on these cables. You got to kind of move the cables a little bit to get the jaws in there, and remember that the little amp clamp's not a pair of pliers, so you can break it. But you can get around these cables and see. I end up finding out that the majority of my draw, almost all of it, is going to the underhood fuse block. All right, so there's a big red cable that goes across the engine bay because the battery's over on the passenger side, underhood fuse box over on the driver's side, and there's a big cable that goes over there. Majority of my draw is there. Cool. All right, makes sense. I'm not super surprised. That's going to feed the majority of the rest of the car, right? There's things, again, like the alternator, the starter, the power steering control module, and a separate path that goes to the interior fuse block, but a lot of stuff runs through the underhood fuse block. Okay, so I move over there and I set up my amp clamp so that I can actually see the draw while I'm checking things, right? Because one thing you want to consider or be aware of as you're checking for a draw, as you're moving through it, is you want to have something set up so that you can assure yourself that the draw is still there, right? I've had that happen to me before where I'm in the middle of checking a draw and then it goes away. Maybe it's intermittent. Maybe I didn't wait long enough for the car to go to sleep. I don't think that's the case here in this situation, but it's happened. So I set up my amp clamp at the back of the fuse box so I can see it. It's the big cable going into the back of the fuse box. So I can see it right there. Okay, I've got my draw. And now I'm going to use the amp hound and I'm going to check all of the fuses in the underhood fuse block because there's a bunch of them and we'll see what's going on. So amp clamp, or I'm sorry, the amp hound is what I'm using to measure the voltage drop across fuses. You can use a meter and the chart that's online, I think from Power Probe, to do the same thing. But if there's current moving through a fuse, it's going to be voltage drop. This tool does the calculations so that you could tell it what kind of fuse you're looking at, and it's going to tell you roughly the amount of current that's going through there. Really helpful tool. I really like it. I use it parasitic draws all the time. Um, what this ends up showing me, and this didn't take very long, I just started poking fuses under there. What this shows me is that the TCM PCM has over an amp of draw. Now there was a small amount of current going through a few other fuses under there, but this one stood out as like, oh, this is over an amp moving through this fuse right now. That should not be the case. Now this is a 15 amp fuse and it's one of those three-pronged fuses. So there's a power in and then there's actually two current paths out. Um, Now you can use um, the leads to figure out, okay, which side of the fuse is it going through? Right, where is the drop? But at that fuse, just looking at it, I don't know which path is going where. Now, I have a diagram up here, and that still doesn't really help you because it's not showing you on the diagram, oh, the middle leg goes here and the outer leg goes there. You don't really know that looking at the fuse, and it would take probably, I don't know, more work than it's worth to really figure that out in the moment. But anyways, I know I have over an amp of current going through this fuse. This little three-prong 15 amp TCM ECM fuse is what it's labeled, 15 amp. And I'm looking at the diagram and it goes to three places. So we have the vent solenoid gets its own direct power feed here. The transmission control module, and it does depend if it's a 6 or an 8 speed. This particular truck was a 6 speed, so modules inside of the transmission, and then the engine control module. That's it. So three things off this fuse. I've got over an amp going through it. I'm not sure if this is my only draw, right? Because I did mention it's a 2.8 amp draw, but this stands out to me in the fuse box is the biggest consumer. Maybe it's not the only one. Maybe I'm zeroing in too quickly on one thing because there could be multiple things awake. But sometimes within a diagnosis, parasitic draw or not, if I see something where I'm like, hey, I know that's not right, let's figure out why that's not right. And it might lead me to the cause of everything. And that's kind of my mindset here why I'm going after this. It just is really standing out as that's a big draw on this thing. Let's figure out why it's there. But again, I have three things off of this fuse here. The vent solenoid, transmission control, and the engine control module. So what I do here is I'm just going to pull the fuse out and see what happens. Now, I'm not a big let's pull the fuses out right away kind of guy when I'm doing parasitic draws. But in this case, because I have such a big draw on this, I want to see how the rest of the car reacts. If I pull this out, does the rest of the electrical system go to sleep? Does my draw go to where it needs to? And as soon as I pull this fuse out, draw goes to about 0.38 amps, so 380 milliamps for a couple of minutes, maybe 2, 3 minutes, and then it drops below 50 milliamps. So my draw is gone. I've lucked out, and whatever is going on this fuse definitely has to do with the overall draw. Now, the interesting thing here, I thought, was when I put the fuse back in, the draw did not come back. I'm like, oh, dang it. I screwed this up now. And that's the disadvantage to unplugging things sometimes is you can fix a problem and then is it going to come back? Am I going to be able to duplicate this again? And that was my thought. I'm like, oh man, I shouldn't have yanked that fuse because maybe I can't get this thing to draw again. Now, I am thinking in my head, okay, this is screaming module to me, something that's drawing, you remove power, you put it back, now it's not drawing. That's screaming module to me, but I have to see if I can replicate this again. Luckily for me, doing a key cycle and flipping the door latch got me back to the same spot when I put that fuse back in, right? So I put the 15 back in, go cycle the key, open and close the door, and note that on GM vehicles, if you have the door latch closed and you go to do a key cycle, your radio and accessory relay is going to be on in the vehicle for 10 minutes unless you open and close that door again. Just ask me how I know that. So I do that. I get it back to the state. It's drawing again. Same amount. And I'm again zeroed in on this ECM TCM fuse, because removing it seemed to remove the entire draw of the vehicle, right? There's about, well, maybe a couple amps still unaccounted for, but for whatever reason, removing this took everything away. So I'm focused in on this, even though it's not my entire draw. Again, I can figure out what is going on this circuit, and odds are it's going to take care of my entire problem. So that's the direction that I've decided to take here. Now, this could be a situation where network's awake. In this particular case, I didn't scope it. A different situation, I might have looked at the network. I just didn't happen to do it here. And I'm walking you through the exact path that I took when I diagnosed this. And I always try to do that, share my mindset, share my process. Um, I didn't scope the network in this case. I was focused. I wouldn't even say tunnel vision, but I was zeroed in on this fuse, and I'm going to figure out what this has to do with it. Why is it causing the draw? I've only got 3 components to go on here, so it should be fairly easy to figure out what the issue is, especially because I can replicate it. So anyways, I'm not thinking the vent solenoid is my issue on here, again, because if I remove that fuse, put it back in, the draw didn't come back. So I'm thinking module. So that gets me down to engine control module and transmission control module. So I have the engine control module literally right in front of me where I'm standing under the hood. Okay, the under hood fuse block is on that driver's side near the fender, and the ECM is right next to it. It's got 3 big connectors. And so the first thing I did was I just unplugged the ECM. I took the 3 connectors off and watched my draw. It's still there. It did not change anything, maybe a few milliamps, but the overall draw is still there. Okay, so again, vent solenoid, maybe a possibility. I haven't eliminated that, but the TCM is kind of the one that's screaming at me right now. So this is under the vehicle because it's a 6-speed. It's inside the, or, in the transmission, behind the pan, part of the valve body. And so I got to climb under there if I want to unplug that. I'm lazy, so I don't do that. This is an interesting choice I made in the moment, and it got me farther in the diagnosis. Now, looking back on it, it didn't really make sense what I was doing if I had thought about it maybe a little bit more thoroughly. But I was looking at the electrical diagrams specifically for the transmission, and I was just looking to see, okay, are there any other power feeds into this thing? Can I remove those? And this is literally just because I'm lazy and I don't want to crawl under the vehicle. I see that there's only 2 power feeds into the TCM, and I have the diagram up here so you can see that. There's the TCM ECM fuse, the 3-prong 15. I remove it, the draw is gone. That's hot at all times. There's also a trans ignition fuse, also in the underhood fuse block, so I don't have to go far. And that one supplies power when the key's on to the TCM. So I pull that fuse and just see what happens. This is a 15 amp fuse as well. When I pull that fuse, the draw also goes away. So this is the trans ignition fuse, 15 amp to the TCM. So I pretty much confirmed that the TCM has something to do with this, that it is causing the draw on this vehicle. But when I remove that fuse, the draw goes away. Okay, so here's the interesting thing though. That fuse should only have power on it when the key is on. The key is definitely not on. Well, maybe that's my problem. Maybe that's where I need to go. So I was thinking in the moment, I'm like, well, wait a second, the ignition fuse, there's not supposed to be power there. Let's see where that comes from. And if you look at the diagram, it gets its power from the ignition main relay, which in fact is only turned on when the key is on. The ignition main relay makes sense. Now this feeds some other fuses as well, several of them in the underhood fuse block, but the trans ignition fuse being one of them. Now that fuse not only feeds the transmission, it also feeds the front axle engagement actuator. But all of this should only have power when the key is on. So let's put that fuse back in and just see, does it have power on it? I mean, it must. There's got to be something going on that circuit in order to wake up the TCM, I'm assuming. And then when I pull it, it removes that, and then the TCM goes to sleep the way that it's supposed to. So there has to be, but there shouldn't be. So let's confirm that with some sort of test. So I take my test light, I ground it, I touch it to the fuse. It does not light my test light. I was like, that's interesting. And I just confirm again, if I pull it out, it kills the draw. The TCM goes to sleep. I'm like, that's strange. I don't see power there, but there appears to be power there. On ignition feed circuits, especially to control modules, maybe some sort of wake up circuit, which I would consider this. One thing that you want to consider if you're looking for power there is a test light, which demands a little bit of current draw, may not show you everything. You might need to get a meter or a scope on here. And that's the next check that I did. Again, because pulling it pretty much proves to me that something's going on in that circuit, but my test light, which draws about a quarter of an amp to light up, doesn't show me anything. But when I check with a meter, and you could easily do this with a scope as well, I find I got 4 volts on this fuse. Now, if you look at the picture, I actually have the fuse removed because I wanted to see, okay, which side of this fuse is the power on. And I have about 4 volts with the fuse removed, which is the power feed to that fuse, with the other side goes to the TCM, right? So pulling the fuse kills the TCM, but there's 4 volts there, which explains why it didn't light up my test light. Not enough current there to light a test light. But that must be enough voltage where if the module receives that on that circuit, it considers that a wake up signal, or that's enough to keep that module awake and talking until that voltage goes away. This episode is brought to you by L1 Automotive Training and Keith Perkins. If you're looking for education on module programming, J2534, EEPROM work, key and immobilizer, electrical diagnostics, or drivability diagnostics, Keith has a website, l1training.com, that's got over 60 hours of training videos on all those subjects and more. When I first started out doing mobile, I utilized Keith's videos on module programming in J2534 in order to get my head wrapped around what I would need for the tooling, the computers, the software setups, what kind of obstacles I would be up against when I'm out there programming modules on cars. And it was a huge benefit to me. And I continue to use the training videos that he has on his website. So I strongly recommend checking out l1training.com. The link is in the show notes. That voltage goes away. So the next thing I do is I want to know where this voltage is coming from. And assuming it's coming from the feed side of the fuse, right? The ignition main relay side of the fuse. Is it coming from the ignition main relay itself? I don't know. Is it internal to the underhood fuse box? Is there corrosion? I don't know. But let's start poking around and seeing what I can find. Now, I'm going to use the diagram here to help me understand where this trans ignition fuse gets its power from and what else it's connected to. Now, there just happens to be a 10 amp fuse, which is labeled the miscellaneous ignition fuse, that is physically right next to it in the fuse box. It's the next one over, little 10 amp, but it's also connected to the same power feed. So I'm like, okay, let's check this fuse and see what this fuse has on it. It has the same amount of voltage. Now, if I put the 15 back in, it actually drops to just under 3 volts, but the voltage is still there. So the 15 amp to the TCM ignition, the 10 amp, which is miscellaneous ignition, they get power from the same source, ignition main relay, but they have like a stray voltage on there that I'm pretty certain should not be there. We should not have 3 volts on this circuit when the key is off. So I feel like this is being backfed from another circuit to these fuses. And again, just happens to be enough to keep the TCM awake. But I've got to try to figure out where. So the next thing I do is I'm like, well, I'm just going to pull this 10 amp ignition fuse, right? to see, does this change my situation or not? And what I can eliminate by pulling fuses, and I'll have to look at the diagram to see all of the fuses that are on this same leg, right? There's a bus inside this fuse box off of the ignition main relay, and it connects to the power side feed of several different fuses. And again, one of these just happened to be this 10 amp that's right next to my trans ignition fuse. You can see in the picture. If I remove that fuse, that 10 amp miscellaneous ignition fuse, the voltage goes away from the trans ignition circuit and the draw goes away. Oh, okay. So I found it. And I did. I got lucky here. It's right there. It has voltage on it. Let's pull it. See, does that change anything? I can eliminate all those components. Well, no, I can't eliminate all those components because removing that 10 amp fuse, that kills my voltage on that circuit, that kills my draw. Now, on one side of that fuse, there's still voltage. It would be the output side of that fuse, if you will. It's going towards components, not towards the ignition main relay. But I've now narrowed myself down to, okay, this is where the voltage is coming from. And this is where I mentioned earlier in the episode, the component that was drawing or causing the draw on the battery, nothing was wrong with it, right? And I haven't gotten to the conclusion yet, but there was nothing wrong with the transmission control module. It was receiving voltage on its ignition wake-up circuit that just happened to be enough to keep it awake. And what was interesting was once I removed that TCM fuse, removed the 3 volts that it was getting and put it back in, that wasn't enough to wake it back up. It was only enough to keep it awake after the key had been turned on, which I found interesting, but with wake-up circuits, you can have things like that. Anyways, I'm away from the TCM now. That's not the cause of my problem. This voltage on the circuit is the cause of the problem, but I got to figure out where that's coming from. Okay, let's look at the miscellaneous ignition fuse. What does that feed? Because what it feeds is actually where the voltage is coming back from. And I look in the diagram, there's only 2 things. It's the right and the left headlamp assembly. And specifically, they call it a multifunction LED control module, but it's a headlight. And it is a violet gray wire that leaves the underhood fuse block and it goes to both the right and the left headlights. Oh, okay, cool. Well, this should be easy. I can just go unplug the headlights, right? And I take a look at the headlights, and this is where had you gone to Identifix, it gives you a visual indicator. Hey, check for this. If this is a problem, unplug the headlights. And I see the right front headlight has significant signs of moisture and actually had some damage as well. There'd been a little fender bender up on the right front of the vehicle. You see the bumper was a little pushed out. One of the plastic arms that stabilizes the headlight was cracked and had like a machine screw in it. And there was moisture inside of the headlight. Not like standing water, but I have a picture. You can see the moisture on the inside of the lens. Okay, well, that's a good obvious thing. Let's unplug that and see what happens. And I unplugged each one of the headlights, which, by the way, is not an easy task. I make it sound easy. Oh, I just unplugged the headlights. It's not. You got to get your hand back there, get a pick. The little red clips are just a pain to get off. It probably took me longer to unplug the headlights than it did to get this far in the diagnostic. But anyways, I did. And unplugging the right front headlight removes the voltage from the circuit and removes the draw overall. Okay, cool. So I found it. It's the right front headlight, and it was. But I am curious here. And even though I'm fairly convinced that the headlight's probably my issue, I do a lot of parasitic draw diagnostics, right? And one of the things that can happen and does happen to me, and a lot of other technicians out there, is you get to a component, you unplug component, and maybe it took you a lot to get to just that point. You're pumped, you're excited, maybe you're just tired of the diagnosis. You're like, yep, that's it, got it, unplugged it, it's good to go. I had a Honda Accord recently where this happened to the technician. He did a good job and he really worked through it to get to the driver's door module. And he unplugged it and the draw went away. And so he put one in there and it didn't fix it. And I've been in that situation too, where like, oh, okay, unplug this thing, this module, this component, especially true with modules, but you unplug it and then draw goes away. So you replace that component. before doing that, I encourage everybody to take a moment, even if it took you a lot to get there, take a moment and just go over the diagram and go over everything related to that component and ask yourself, is there anything else that could cause this component to stay awake, cause a draw, output voltage onto a circuit that's not supposed to be there? That's this situation for sure. And my question here, it should be this should be a question that you have anytime you get to this point of like, is there anything else that is going on or going to this module that shouldn't be, that's causing it to act this way? In a lot of cases, you end up finding that is true. I had a case study on a Cadillac not that long ago with a LED light assembly that was grounding a circuit and causing the BCM to stay awake. And, you know, by all accounts, the BCM looked like the component at fault, but replacing it did nothing. I had to go through circuit by circuit to find the thing that was keeping it awake. And that's always in my mind when I get to this point of like, okay, what else? What else is going on? Because it's not just a one wire component. It's not just power and ground. This particular headlight has 8 pins on this connector here. And my question is for this headlight is, when the key is off, should the headlight be receiving power on another circuit, right? Because what we're experiencing is this miscellaneous ignition fuse is what is supposed to provide power to the headlight when the key is on. Based on the diagram, ignition main relay turns on, power goes through this 10 amp fuse to the headlights on this violet gray wire. Now, I haven't pulled up the full schematic for the headlights, but is that the only power feed, or is there another constant power feed that's going to this? I don't know, but I should definitely figure that out before I tell them for sure that a headlight is going to cause this, right? What I'm saying is there's got to be voltage coming from somewhere else on that headlight in order for it to bleed voltage back onto this circuit. And should that voltage be there in the first place when the key is off? That's my question. I don't know that. I don't have the circuit memorized, so I have to go through and see, is there anything else key off that normally supplies power to these headlights? All right. So I go through the diagrams, and this was not easy. Number one, there's a ton of RPO codes that you have to sort through for a GM truck of this era for headlight schematics, because there's lots of different options. Use repairlinkshop.com, Control F. This can help you out a lot sorting through these diagrams. You can use a sticker in the glove box as well, but you will need this in order to get the correct diagram. But I'm going through the diagram, and the only other power feed that I see to the headlights is a high beam relay that provides power when the high beams are on. And this is on a white wire. I checked this, there's no power there. No voltage, not lighting up a test light either. There's nothing there, as it should be. This shouldn't have any power. So I'm racking my brain, I'm going through the diagram, and I don't see anything else. Everything else is a control of some sort, it would seem, to this headlight connector. I was like, that's strange. Well, let's do this. Let's just go through the connector, because I don't see anything obvious on the diagram that screams to me, hey, power's here all the time. Let's go through on the connector itself and see what has power on it. So I unplug the headlight, I'm using my voltmeter, and I see about 11 volts on one of the wires. And my battery might have been getting low here, but either way, it's somewhat close to battery voltage, but 11 volts on this circuit. And this is a white blue wire, which I don't see in the redrawn diagram. And I go through the entire thing. There's like 5 pages. There's no white blue wire going to the right front headlight anywhere on it. And if you look at the headlight in the diagram, it's got that dotted line around it, which means, hey, there's more circuits, but we're not going to show them to you in this diagram. You got to go look elsewhere. So again, roughly 11 volts here. Now that's the only other circuit that has power on it. Now I plug it in, and it actually drops down a little bit, but then you see the voltage come back out on the other side, this violet gray, which then goes back feeds up to the miscellaneous ignition fuse, to the TCM, so on and so forth. But I'm looking at the source here. And again, my only question is this supposed to be here? Maybe it is. So let's go to the OE diagrams. I was using redrawns. OE might include what I need to see. Again, here's where your RPO codes are going to come in handy, because there's 1, 2, 3, 4, 5, 6 different possibilities for headlight schematics, depending on your RPO code. So you're going to want to know what it is. There's also running daytime running lamps diagrams as well. I pull up all of these. I can't find this freaking wire. Like, well, it has to exist. It's on the circuit, but it is not in the OE diagrams for headlights. It is not in the redrawns for headlights. And so this is a picture in the video of the actual OE diagram, and you can see the miscellaneous ignition fuse. You can see the high beam relay. You can see another yellow wire coming from the BCM that has a power feed. I believe this is a control of some sort, but I don't have any power there. But I don't see my white blue wire that I have in front of me on the car that has 11 volts on it. So in this case, I don't see it on either diagram. Let's look up the connector view. And this is the X120 connector at the headlight, 8 pins. Pull it up. Oh, well, pin 5, white, blue. That's my wire that has power on it. What does it say? It says right headlamp bulb out signal. Okay, so is this like an outage signal from the control module, which is the headlight, back to, I don't know, BCM maybe? I'm not sure. It's not on the diagram, but maybe it's on a different diagram. Maybe we got to do a little bit more digging. And this was more curiosity for me than anything. But again, I want to make sure that there's not supposed to be voltage here all the time, because it's bleeding through the headlight on the right side. And I did check the left side. It also had power on the same circuit, but it wasn't bleeding through on that headlight. I did find this. If you look up the turn or the exterior light diagrams, which is actually the turn signal diagrams, you can find this pin 5 white blue wire that goes to the right headlamp assembly. There's one that goes to the left headlamp assembly. It's a different wire color. And if you look at the diagram, you can see the BCM has this monitoring circuit with a power feed through a resistor. It's a monitoring circuit and has a little picture, which I wasn't familiar with. I actually had to look up. It's a black circle with 2 arrows pointing in a angled downward direction away from the black circle. So again, it's on the video if you want to see it. I wasn't familiar what that is. You can look these up in ALLDATA. Like, hey, I don't know what that symbol means. It has a whole chart of what you can look this, and it shows you what the diagrams symbols mean. It's bulb out is what that means. Black circle, 2 arrows going down, bulb out. So it's a bulb outage circuit. Okay. So that's exactly what this is a monitoring circuit for the BCM that the headlamp assembly will do something to this circuit to indicate that the bulb's out. Now, interestingly enough, in the diagram, the factory diagram, if you look at it, it just says this wire's grounded all the time. I don't believe that's true. I'm guessing it probably grounds it if the headlight's out. Maybe it grounds it if everything's good. I really am not sure, but something has to change in this, I would imagine, in order for the BCM to tell whether or not the bulb is actually out. It can't just be grounded all the time. It wouldn't be able to change status if the bulb actually went out. So the diagram might be a little bit misleading there. There's actually another part about this diagram that I think is incorrect. And this is kind of why I wanted to point out this part of it. Like, why are you going through wiring diagrams on a podcast? So yeah, if you're ever digging into this, you're going to see this. You're like, well, that doesn't make any sense. It has the wire joined to another circuit that says door lock indicator schematics, right? So the white blue wire goes through the underhood fuse block and then leaves on a separate circuit and goes to the BCM, but it has another leg off of that wire that says door lock schematics. So I pulled that up and it goes to a little lock symbol on the BCM. And it says door, what does it say? Door lock, switch unlock signal. And it actually goes to the driver's door latch assembly. Now, I don't think this is accurate because looking at this part of the diagram, the driver's door latch assembly actually grounds this circuit when the door is locked. And it says if you look at the redrawn diagram for the BCM on this circuit, it says switch unlock signal. I don't think this is actually tied to the headlight circuit. So something is incorrect here with the diagrams. And I just wanted to point that out. If you ever go down this route, you're chasing this is not accurate. Now, what I can say is that the BCM is monitoring this circuit for a bulb outage. Okay, now the actual pinout, I didn't go quite that far. What I did find was if I left the headlight unplugged long enough, this voltage would actually drop down to nothing, the output voltage from the BCM. So something about that headlight assembly maybe being shorted internally was keeping the BCM producing voltage on that circuit, that monitoring circuit, but it eventually did shut down. And I actually found the same thing on the BCM of that Cadillac. Is you give it enough time and the output monitoring voltages will actually go to rest. But if something is affecting those circuits, it's going to keep it on. It will keep outputting that monitoring voltage, which is what was happening here. So anyways, the cause of it was the right front headlight. There's nothing more to it than that. And the only other constant voltage to these headlights are these bulb outage signals. But finding that wire on the diagram is not an easy thing. And this is kind of why I'm mentioning this here in case you go down this route and you see voltage on there. Where is this coming from? It's not making any sense. It's a bulb outage circuit for the BCM to monitor their headlights. And although I wouldn't say it's always supposed to be voltage there, in a case like this, it can be. But the headlight's a problem, and it's easy enough to unplug it, monitor the rest of the circuitry, and figure that out. And the water is a dead giveaway too. So you can jump ahead to the conclusion and just do a visual inspection of the headlight assemblies and find it pretty quickly. But that's what I got for you today. Hopefully you found that interesting, helpful. Maybe it gets you to the conclusion quicker or helps you out with some parasitic draws in the future. But that's all I got. So let's get out there, start fixing the world one car at a time.